In the last video, we have introduced mathematical analysis. And in this video, we will start studying mathematical analysis. So let's start with the concept of absolute value. So let's first define what absolute value means. Well, absolute value is a function that maps from the set of real numbers to the interval 0 to infinity, and it is defined as x if x is greater than or equal to 0 and negative x if x is smaller than or equal to 0. So, what is the geometric meaning behind this definition? Well, if we are given two real numbers x and y, the absolute value of x minus y is the distance between x and y on the real line. So, using this geometrical meaning, we can introduce some properties of absolute value. The first property of absolute value is that if there's a number such that the absolute value is equal to 0, this is equivalent to saying that x is equal to 0. Well, you may wonder why. The reason is that if we rewrite this absolute x equal to 0 to absolute x minus 0, then we see that this is the distance between x and 0. And what this statement is saying is that the distance between x and 0 is 0. So this is equivalent to saying that x is equal to 0, right? From this property, we can introduce something that if we're given two real numbers, if the absolute value of x minus y is equal to 0, then it is equivalent to saying that x minus y is equal to 0. It follows from the above statement. And if we put the y at the right hand side, we get x equal to y. What does it mean? It means that if the two numbers are in the same point, then they are indeed the same real number. And the second property is that the absolute value of x minus y is equal to the absolute value of y minus x. Well, the reason is clear if we have introduced the concept of the distance. Well, the left-hand side is indeed the distance between x and y, and the right-hand side should be the distance between y and x. So it's very clear that these two distances should be equal. So the next property is the triangle inequality. What the triangle inequality is saying is that given two real numbers x and y, we have the absolute value of x plus y should be smaller than or equal to the absolute value of x plus the absolute value of y. And we are going to prove it. The proof is that we should observe that the absolute value of x should be greater than or equal to the x. And so, given two real numbers x and y, we should expect to see absolute value of x times y should be greater than or equal to x times y. So, what we do next is to multiply the 2 to both sides. And after multiplying 2 to both sides, we add x squared plus y squared to both sides. We add these two. Well, the next step, we need an explanation. Well, first of all, we should observe that the x squared should be equal to the absolute value of x and then square. The reason is that if we square something, the sign of x should be neglected. And similarly, we can prove that the absolute value of x times y should be equal to absolute value of x times the absolute value of y. And so, we obtain the left-hand side, and the right-hand side remain intact. And using the identity a plus b squared equal to a squared plus 2ab plus b squared, we see that the left-hand side become the absolute value of x plus absolute value of y squared greater than or equal to the x plus y squared. And the next step is that we take a square root to both sides. But we should explain why we can take the square root to both sides. The reason is that first, the left-hand side and right-hand side are greater than or equal to 0 because they are squares. So, we are legal to take the square root if the number is positive. Second, why taking square root will preserve this inequality sign is because, indeed, fx equal to square root of x is an increasing function on the interval 0 to infinity. And so, when we take the square root, it indeed preserves the inequality sign. So, after we take the square root, we have to remove it. So, what can we do? Well, next, we should notice that the square root of x squared should be equal to the absolute value of x. So, when we take away this square sign from the square root, we see that the left-hand side becomes absolute value of the absolute value of x plus absolute value of y, and the right-hand side becomes absolute value of x plus y. But there is one more thing that is missing. In a triangle inequality, we do not have this absolute sign. But I'm going to tell you that this can be taken away. Why? Because notice that the absolute value of x and absolute value of y are all greater than or equal to 0. So when I sum them up, it should be greater than or equal to 0 as well. So, by definition of absolute value, this the absolute value sign here can be taken away. So, when I call this star, we obtain that the absolute value of x plus the absolute value of y should be greater than or equal to x plus y. And this is the end of the proof of triangle inequality. So, from the triangle inequality, we also see that the absolute value of x minus y should be equal to the absolute value of x minus z plus z minus y. Why? Because these two terms should be cancelled, and this whole thing should be equal to x minus y again. But this tells us that this x minus y absolute value should be smaller than or equal to the absolute value of x minus z plus the absolute value of z minus y. Well, you will wonder what is the meaning of this inequality. Well, the meaning is that if x is smaller than z, is close to z, and z is close to y, you can see this picture, x is close to z, and z is close to y. And this inequality is telling us that indeed this implies that x is close to y. And this is pretty intuitive because you can visualize it, right? So this is the end of the video about absolute value, and I will see you in the next video.